Welcome to Alternative Energy Materials, where we're revolutionizing energy storage with a brand new green ammonia technology. We're not just solving one problem, we're solving two by making a distributed energy solution that is affordable, sustainable, and dual purpose, solving backup power and green fertilizer for farmers. The first problem we're solving is the reliability of the grid. Weather events and equipment outages can prevent utilities from getting critical power to their substations for days at a time. But the existing technology of lithium-ion batteries can work only as a band-aid for a few hours of backup power. Data centers and critical infrastructure need days or weeks of backup on site. And at the same time, utilities are subject to new regulations requiring them to accept even more renewables onto their already strained systems. We have a solution for this. And that solution also solves a second crisis, the crisis our farmers face with the exorbitant costs they're having to pay for ammonia-based fertilizers. This is the second most commonly produced chemical in the world, and it contributes over 1% of our global greenhouse budget. Farmers over the past few years have been paying over $750 to $1,700 a ton to have the fertilizer delivered to their farm. They're subject to the global price variations of this global supply chain that's vulnerable. We have a solution of locally produced sustainable ammonia that gives reliable, low-cost production to the farmers and addresses the utility concerns for reliability. We do that with one system. The utilities see it as 100% cost savings for backup power because it's a system that can pay for itself by selling the ammonia offtake to the farmers. They get hundreds of hours of backup power at each site and can increase their renewable portfolio by diverting excess capacity in times of excess renewable energy to produce this green ammonia offtake. The farmers get a locally produced, reliable, low-cost supply for their fertilizer. And investors will love this technology. It can have up to 80% gross margins on the product we deliver to the utilities. It's a dual revenue system with equipment sales and payment for ammonia offtake. And it has huge follow-on markets when we start considering using ammonia for fuel purposes in heavy trucking, shipping, and marine applications. It's one system, two revenue streams, and zero emissions. The breakthrough technology is what I've been working on for 18 years. I've been working on solid oxide technology since I started my PhD working for clean coal. The world's moved on from clean coal, but what we've been able to accomplish in the meantime is a ceramic reactor that miniaturizes the process. By working at extremely high pressure, we can have tiny microchannels and fit 2,000 layers into a ceramic block the size of a house brick. This high pressure operation gives us incredible conversion efficiency and is perfectly reversible, so we can run it to make ammonia or to make power. The critical element also is that we've eliminated all of the hydrogen compression. We pump liquid water in and produce the hydrogen at the ammonia synthesis pressure. This gets rid of tremendous costs in the overall balance of plant. The key to this, it's patented. We have secured the rights to the fundamental composition of the material that allows us to make this high pressure electrolyzer. Let's compare this to batteries today. The energy density of ammonia is 10 to 20 times greater, and storing it just takes a simple steel tank. These large steel bullets cost about 30 cents a kilowatt hour compared to $300 a kilowatt hour for lithium battery capacity. The duration of storage can now be measured in weeks. A single 200-ton bullet could hold 360 hours of storage for a substation. Designing these with the lifespan in mind of a substation, we're designing for a 20-year life. It's solid state like a battery and can cycle repeatedly. It's far safer than the battery. We don't have a thermal runaway risk. If it catches fire, it's not hard to put out. And catching fire on ammonia is actually rather difficult to do. It is costly. It has some safety concerns, but farmers have been doing this for decades and we're well accustomed to how to work with ammonia. The footprint is much more compact than a battery and the cost is roughly a third. We don't have nearly the critical materials challenges that you have sourcing lithium and cobalt and the other exotic materials in modern batteries. Key to this protected innovation, this patented high pressure electrode, is that we can replace all of that costly and energy intensive hydrogen compression with a simple water pump. By shrinking it down into the size of a brick, we're actually getting better thermal integration too, which improves the total conversion efficiency of power to ammonia. More ammonia out for the same energy in. Different from all of our competitors, we've unlocked this really fascinating reinforcing synergy. As we double the pressure, we can use smaller channels, which makes the device smaller. At the same time, higher pressure improves the chemical activity. So doubling the pressure results in 4 times the power. And that's why we're able to get so much power and reaction into something the size of a brick by operating at 200 atmospheres. By making it smaller, we've gotten rid of 95% of the mass. That's 95% less mass we need to heat and cool and operate when we cycle. That means we can operate faster, and we can follow the dynamics of wind and solar power on hourly cycles and quickly transition from being a ammonia producing plant to a power producing plant. AEM's ceramic electrolyzer technology is a relatively simple solution, but it has lots of applications. The key application we're starting with is the substation backup power support with ammonia offtake for farmers. But the system works just as well on the farm, producing the ammonia to fertilize the fields and maybe one day power the tractors as well. This is also a grid scale energy storage solution that can work for hyperscale data centers and make these data centers completely independent of the grid if they have enough renewable power on site. Long term, we want to expand into those transport markets. We want to produce the ammonia for ships, trucks, and trains to power the future without fossil fuels. The market opportunity for all of those different end users gets really big really fast. But it starts with our utility substation case. Our first generation system we plan to deploy in just a couple of years, selling 10 of these a year will generate 75 to 100 million in annual revenue. And very quickly, as we scale up production, that expands out to over $1 billion a year just servicing that substation and farmer ammonia market. As we grow from there to service the larger renewable energy firming market, it grows domestically to over $100 billion a year. And then we begin tackling the heavy transport of marine shipping, trains, and trucks. And that is the real target at the end of the road. Our initial go-to-market strategy is focused here in Eastern Washington, and it's a great market to start in because it has some key features that work well with this technology. We have a stable, recurring agricultural offtake user for that anhydrous ammonia that is at scale. It's a $200 million fertilizer market just in Washington, 260,000 tons of ammonia put on our crops every year. We're very renewable energy rich in this region. Between the immense hydropower, the solar and wind potential, there is tremendous renewable that's going to waste at the moment. And it's a capacity constrained grid. This storage solution alleviates that capacity in the critical days and hours when wholesale prices are at their highest. What we can give is reliable 360-hour storage at 100 substations. At that scale, we would satisfy the majority of the farmers' anhydrous needs, and we would be providing over 300 megawatts of dispatchable power to the utilities. That operation would consume 2 terawatt hours of renewable energy that the utilities would get credit for moving on their network. And they would get credit for reducing imported emissions by 600,000 tons per year. This is huge in our compliance mandated era. The unit economics for our systems are fairly simple. About 6,500 hours a year, the wholesale energy price in our region is $40 a megawatt hour or below. At our production efficiency of 7.5 megawatt hours a ton, that's equivalent to $300 a ton ammonia. Wholesale prices have fluctuated between $400 and $600 a ton recently, so we're profitable on a day-to-day basis. The backup power, when the grid needs it most, runs anywhere from $125, sometimes up to $1,000 a megawatt hour. But we average those out and reliably produce 500 hours per year of backup power, as well as the 2,000 tons of ammonia. This is generating over $1.3 million of revenue per year for the utilities and justifying our $10 to $15 million equipment sale price. Our roadmap is fairly short between where we are today and being cash flow positive. Over the next 2 years, we're optimizing the manufacture of the brick to be able to produce these at scale quickly and optimizing the performance in larger test stations. We're going to design the brick house, which is the balance of plant system that goes around and provides the water and captures the ammonia with refrigerant, a condensing refrigerator. In just 2 years, we'll be piloting this with our local utility at a field site and building out the lean manufacturing plant with our CEO, Chris, leading the lean development of that pilot plant as we move into production of 50 or more systems a year in just a couple years. And that is the cash flow positive timeline. At that point, we should be seeing widespread utility deployment and starting to expand the technology to serve heavy transport markets. The leadership of the company is myself. I founded the company, invented the technology, and I've brought on Chris Wood, who's been a just fantastic champion of anhydrous ammonia. A farmer himself, knows all the challenges that are faced by the farmers trying to budget every year for a wildly variable input cost. And he's also happens to be one of the world's experts in lean manufacturing and scaling technologies to production. Absolutely thrilled to be working with him as we move from this phase of what was previously a science experiment and now into the manufacturing challenges as we scale the technology. We're also supported by a world-class team of advisors, both regionally and nationally. Bill Fuglavon, John Gibson, David Peterson, and my former PhD advisor, Jack Brower, Mr. Fuel Cells, all bringing their expertise to guide us through this difficult challenge. So as I wrap up, let me remind you about a few key points about alternative energy materials. We are the market leader, the first mover in this space of a backup power solution with its own revenue stream of ammonia offtake for the farmers. We've patented this technology. It is protected and secure. This is a technology that produces multiple revenue streams. We can sell the equipment and the ammonia offtake. We are a sustainable leader. This is a true zero carbon solution for green ammonia in an infrastructure grade asset that will last decades. And finally, the long-term upside potential of alternative energy materials is massive. As we move from serving this niche fertilizer market, niche $20 billion market in the United States, we can expand into even larger fuel markets as we work to displace and rid all fossil fuels. So please, join us in scaling storage beyond the realm of batteries to hundreds of hours of storage at critical infrastructure sites. Thank you, and have a wonderful day.